Now let's look at the electrolysis of a molten substance. That is, electrolysis of an aqueous electrolyte. So it means when we say aqueous electrolyte, it means our electrolytic salt, that is the ionic salt that we use as our electrolyte, is dissolved in water before we use it as the electrolyte. So it means we are going to have ions from that our salt and ions from water. So we are having more than 2 ions in this case. So as we use molten sodium chloride here, let us use aqueous sodium chloride here, NaCl, but this time it's going to be aqueous. So when we have NaCl aqueous, so it means NaCl dissolved in water, in H2O. So when we say NaCl dissolved in H2O, what do we mean? We are going to, when NaCl is dissolved in H2O, we are going to have Na plus ion, that is sodium ion. We're going to have Cl minus ion, just like what we have, the way we have it here, Na plus and the Cl minus. But we're going to have 2 more ions. The remaining 2 ions will come from water. Water will also dissociate partially. So when it dissociates, it will dissociate into hydrogen ions and hydroxide ions. Please don't forget, we will have 2 ions contributed from water, H plus and OH minus. So in this case now, in aqueous solution, you're going to have 4 different types of ions, 2 from the salt and 2 from water. Let us look at sodium hydroxide. Let's say our electrolyte is sodium hydroxide solution, NaOH. We can also use a base as our electrolyte. So we have aqueous sodium hydroxide. So what are going to be how many ions are we going to have in the electrolyte here? I want you to predict before I go ahead. Okay, let's say you've predicted, right? Did you predict 1, 2, 3, or 4? So let's see how many ions we have in the solution. Of course, we are going to have Na plus contributed from NaOH and then OH minus as well. From NaOH, we are going to have H plus from water because of this aqueous, and also OH minus from water because water will split into H plus and OH minus. So in total, we have how many types of ions? We have only 3 types of ion in the solution. 3 is the correct answer. OH and OH, no difference, whether it comes from water or from your alkali. Okay, so you can have maximum, at this level, maximum of 4 ions in the solution, a minimum of 3 ions in the solution if you have electrolysis of aqueous substance or aqueous electrolyte. Now, how do we determine which ion will go to the anode, which ion will go to the cathode? Let's label our anode and cathode. This is our anode and this is our cathode. Cathode electron will come from the battery to the cathode, and then electron will go to the battery from the anode. I hope I remember. I believe we can remember that now. Now, in our electrolyte, we have Na plus, Cl minus, OH minus, and H plus. So we have 4 types of ions present in the electrolyte. Of course, we know that, let me write them here, we have anode, and then we have cathode. We are expecting, and let me say at the anode, or let me just write it. Let me break everything down so you will follow along. Let me remove this very fast. So, of course, we are dealing with electrolysis of aqueous sodium chloride solution. So the ions in the electrolyte, the ion in the electrolyte, these ions are going to be Na plus, Cl minus, H plus, and the OH minus. And then remember, Na plus and Cl minus, they are from sodium chloride, and H plus and OH minus, they are from water. Now, we have those 4 ions in the electrolytes. Now, remember, we have 2 electrodes. We have anode, which is our positive electrode, and cathode, which is our negative electrode. So our positive electrode will attract the negative ions, that is, the ions that will go to the anode are Cl minus and the OH minus. The ions that will migrate to the cathode are Na plus and the H plus. But only one of the 2 ions here will be discharged, and only one of the 2 ions here will be discharged. When I say discharged, let's see, discharge. This is how I explain this to my students. You know, this one has a charge now. It has a charge. To discharge means to remove the charge. So discharge, removal of the charge. So when this charge goes away, it means it does not have a charge any longer. It has been discharged. So which of the 2 ions will go to the anode to get discharged? And which of the 2 ions down here will go to the cathode to get discharged? There's a rule for that. We need to follow a rule. There was no rule here. We know that because there was no competition here when we're talking about the electrolysis of molten substances. No competition. Sodium alone goes to the anode. Chloride alone goes to the cathode. Sodium alone goes to the cathode and chloride alone goes to the anode. There was no competition. But here, there will be competition. There are 2, Na plus and H plus. Both of them are supposed to come to the cathode. OH minus and Cl minus, both of them are supposed to come to the, they will migrate to the anode. But only one of them will be discharged when they get to the cathode or get to the anode. So, how did they get discharged? We need to follow some rules in order to understand how they get discharged. So let's look at discharge. I like to start with discharge at the anode. So how will that happen? The rule is very simple. So the rule is that if you have halide ion, I'll write it, if you have halide ions, what are halide ions? That is the ions of halogens like Cl minus, like Br minus, like I minus. These are halide. So if you have halide ions in the electrolytes, and I'll put and, it is important, and they are concentrated. So what I mean by they are concentrated is that they will mention that in the question. They will say electrolysis of concentrated sodium chloride, or they say electrolysis of dilute sodium chloride. So when they say electrolysis of concentrated sodium chloride, it means the chloride in that electrolyte is concentrated. So that's what we mean here. If you have halide and they are concentrated, so if they don't mention concentrated, so you assume that it is dilute. You can also know what happens if they don't mention either, but they will mention either concentrated or diluted for you. Now, if you have halide ions in the solution and the solution is concentrated, so what will form, that is, let me just write it. I will say the halide. Can I say halide? I will say halogen. Halogen will be produced at the anode. I will say halogen, or let me say halide. I will say halide ion, halide ions will be discharged, and a halogen, halogen will be produced at the anode. No, we're talking about the anode, so I may not put this one. I'll just say will be produced. Again, in the electrolyte, you have halide ion. For example, what we're discussing, we're talking about sodium chloride. So if our sodium chloride solution is concentrated, if it is conc, sodium chloride solution, you are expected the chloride to be discharged at the anode. Remember, the competition is between the chloride and the hydroxide. So if this solution is concentrated, it means you have concentrated chloride ions in the solution. So because chloride ions are more concentrated than hydroxide ion, they will be discharged at the anode. So that is the rule number one. Now, if that's number one regarding the anode, so the opposite is the case actually. So if the solution is dilute, that is, you have dilute halide ion in the solution. Again, if the solution is dilute, so instead of having conc halide ion in the solution is dilute. Now you have dilute solution of halide ion. So that's one. Or halide or halides let me just say halide or halide is absent in the solution. So let's go ahead first. Halide is absent in the solution. I will say hydroxide ion, that is OH minus, hydroxide ions, that is OH minus, will be discharged. Now, the solution is dilute instead of concentrated. So you have halide solution, but it is dilute, or you don't have halide at all in that solution. For example, if it is electrolysis of sodium carbonate, Na2CO3, rather than sodium chloride. So it means this case, halide is absent. So there's no halide in this case. So it means OH minus will be discharged. That is OH minus from water. Remember, H plus and OH minus. So this one will be discharged. Or if you have halide, for example, you still have sodium chloride, but that solution is dilute. So this guy will not be discharged again. So rather, it is OH minus that will be discharged. So those are the two scenarios. The two scenarios that explain what will happen at the anode. When you have halide present, the solution is concentrated and halide is present, or you have a concentrated halide solution in the electrolyte, halide will be discharged. But if the solution is dilute, that is dilute halide solution, or you don't have halide at all, the OH minus from water will be discharged. That is it at the anode.